Hi, this is Bill Kearns from Blue Kernel IT. This video is about a console application I wrote that does keep alive services for .NET Nuke. So to give you a quick overview, .NET Nuke is an out-of-the-box vendor that supplies a package where you can build really snazzy websites very quickly that are run in ASP.NET. It's very user-friendly and there's a lot of features and plugins. One feature of .NET Nuke is the keep alive service. So you have to hit the .NET Nuke website, more or less ping it as an HTTP request so that it keeps the site alive and compiled and you get a really fast response time. Here is the project I have. It's a Visual Studio 2012 project at this point. I wrote it originally with Visual Studio 2010, about a year and a half ago. I'm going to explain each one of these classes. I'd like to mention the console application is multi-threaded and it makes use of the Entity Framework 4.0. At the time of writing, I was going to port this to a Windows service. However, I found that you could not use the Entity Framework within a Windows service. And that was using Entity Framework 4. I haven't checked recently. So first I'd like to explain the SQL diagram and database diagram that goes along with this project. Personally, I prefer using a database first schema for any Entity Framework work. I personally don't like the idea of an Entity Framework modifying or changing your SQL tables that run in the background. That's just my personal preference. So here I have a SQL file that drops and creates a database, loads the tables, creates a relation, and inserts some system parameters and administrator values that I'll explain later, and the domains to check. So here is a SQL Management Studio database schema. There's only one relation. Here we have domain. The main point of the program is that you'd enter records with URLs and then a verification string optionally that you'd want to check for, meaning you'd hit a website such as Blue Kernel IT, and the website or the program is going to look for the website to see if it loads, get the HTTP status code, and then look for an optional string if you provide the string, something such as introduction. So back to the diagram, you'd have a URL verification string to check for. If you want these checks to be enabled for this URL, and some other information, the server name that it's running on. This isn't being used as the console was written for sites that were hosted locally on various different servers. From there I have a one-to-many relation from domain to status check. Each time the program runs and checks the domain, as long as it is enabled for a check, it logs the results here in status check, which I'll look into later. Beyond that, we have error messages. This is for program error messages, so that if it was in a Windows service, you would have database entries, or any way you run it, you have database entries as to the exceptions that were generated that weren't supposed to happen. You have a system parameters table. This uses pivoted key string and value string. And you have an administrator table. The administrator table is for emails. So there were different versions of emails we needed when I wrote this console app. Each one would have a different email subject and body and contain different data pertaining to how the status check turned out for the URL. So for demo purposes, I have a few URLs listed here. If you notice, I'm leaving off the protocol and the www if it's included. One of the caveats of this program was that for the organization I worked for, we wanted to make sure that all of our host A records had an HTTP www version and just HTTP with no www. I'll explain where that relation comes in a little bit later. Here is the program structure itself, the solution file. I have the SQL file and this site check builder. Site check builder works with website health worker. So site check builder, because the program is multi-threaded, really keeps all of the variables that are used throughout site check in one spot. That way multi-threading issues are avoided, so all the variables here are used one at a time, and threads don't step on each other. Most of these, when they're used, are passed by ref, in the website health worker. If they need to be. So the structure of this program, you run the console app. Here's the console. I start by creating an instance of the website health entity store. The entity store is a class that I created as a singleton. This singleton keeps any lists of entities in their object form from the ORM that are detached from the actual entity store. And I do this so that threads can run and add items to this list, and only at a certain time that I would choose would this list of entities be synchronized with the actual complete website health entity store. So this object here, website health entities, is the EDMX file. Here is the actual entity, Microsoft Entity 4.0 EDMX. This was generated just based on the database values, tables. So a little bit more about that. Website Health Entity Store is a singleton, and I also put all the program locks in this class so that these lists are locked, which multiple threads can add detached entities to these lists that functions more or less as a query, and then down the road they're saved to the store. So to add any entities to the store that are detached, or to update any of the entities that are within the store, I have locks. So all the locks in the entire console app are in this file. You could think of it as a data access layer for the entity store. So there's save status checks, quite a few method signatures, add to current checks, add to messages. This adds to the query lists, and these update methods update what's in the current entity store, and some of these save methods actually save to the database what's in the entity store, which is called incrementally as threads run. So let's talk about the threads. From the console, once I have my entity store in memory, before I forget, part of the paradigm here I'm using the try get object by key. So the entity framework creates its own internal keys. Going through my query list of error messages, that's one of the entity types, and creating a key and then checking if it exists. This was recommended, even though it seems redundant to create one. So then if it's not in there, we go ahead and add it to the store, and then we save changes. So back to the console. After I create the entity store, eventually after the program runs and saves the results, it also sends an email of formatted HTML message so that you can get the results of the website check. So this part here does a test message to make sure your email client's up. I usually have that commented out. And then we create our thread objects. So this loop here goes through each domain from the entity store and adds it to a list. I found a good extension method online, split. So what this does is splits the original list, which could be any amount of domains, up into a list of lists at 10 domains per list. I did this so that each thread would be responsible for 10 domain checks rather than having one domain check per thread. So that's how it's multi-threaded. So from there, it returns the list. And here we have thread pool query user work item. So the work item is each list of site check builder, and we're querying one. I'm using the thread counter. So this thread will actually wait infinitely. This is something that should be modified in the future until the thread lock returns a certain number of the total amount of threads that it had to run. So here in website worker, now that I have my entity store in good shape and newed up, and the site check builder is built and separated into lists, then I go ahead and run these two methods here. There's check site and check domain. Check site runs first. This is the actual signature that I'm using to start the thread check delegate. So this object is actually an instance of site check builder. So then we go through. The reason I did it this way is for the variations. The variations were added down the road. That would be http://www and just http:// and then the domain name. So the worker works with the thread state objects. It runs through this method. This is a bit I'm not using. Looks for status OK, status found, move permanently, and it calls this second method here, check domain. This actually does the check. Part of the challenge of this application is that by default, the .NET framework, if there is not a status of HTTP OK, actually throws an exception. So this is something a little unconventional. I have to return to the code and loop out of a catch block. I'm at the mercy of the .NET framework on that one. So the rest of these static methods that I wrote just format the results from the check into what you'll see in the email. So now I'll go ahead and fire up the application. I only have 2 debug points enabled, the one at the very beginning, so I can step through some of this, and I'm just going to hit continue, and this is going to go ahead, split up the threads, and run the tests, and we're going to stop after the thread increment counter has released the thread and the emails are sent. So at that point, it would be here, and then once all the threads stop, this main thread comes back in and sends all the emails. So basically the multi-threaded part is really just for the domain checks. So this would go through and check all the administrator records from the entity store and see, based on the status check, if you want to send an email and which email to send, which email group that belongs to. So here's where it actually sends the email. And here is where I have my breakpoint highlighted. So I also had a system parameters commented out as to how long you want this to sleep. So then very simply the thread would sleep for some interval of time and just go ahead and call the main method again, and the whole program would recurse. So I'm going to pause the video while this goes and runs. So now that the thread execution has stopped and all of those domains were checked, we're at thread.sleep, and the program would go ahead and start over. So here are some of the results of the website checker in my email box. Here's the demo that was ran as the test message, and then we have a website down. So these websites are down. Now you have to have a keen eye here, because really it's not saying it's down. The status code is moved permanently. So if you notice, these are all the variations in the websites I was checking for Wikipedia that use the HTTP www version. If you notice, I go to the websites up email. Go ahead and load that. It says that all these are fine, status OK. This is the domain I checked. This is the string I was looking for, so it found the string. What the program does, once it gets a status code OK, it looks at the response stream that was generated by the server, parses the response stream, and looks for that string that was the validation string. So all these emails are good to go. So in addition to getting an email, you also get the status messages that were saved to the database from the entity framework. So I'm going to select the top 1000 error messages, which is internal, and check this is when I was sending email with the wrong password. The status check. Here we go. Here's the status check. Here's all of them. and which is basically just the same text that I put in the email. And then here are the ones that passed, which you can see I've ran the program several times. And here are the ones that failed. Which consistently I'm getting a move permanently, and each one of these with the www version. So though the program was written with a very specific niche in mind, I would like to expand the program and just introduce for a minute how quickly it could become something else using all the same existing code. If I added one relation here, one-to-many relation, and for each one domain, I had many records. Say a record could be a forms header and then a value, and several of these for that domain. Then with that relation in my entity store, I could very quickly here add any variables to site check builder that I would need, and then very quickly here in the worker class, at the very first method that is the signature method that the thread state runs, after I get my site check that I'm actually using, so this is one domain and all of its information that goes along with it, I could easily add a for loop here that would then go and get the collection of, say, post-back form headers. That way, in addition to doing the check, I could also try to pull another GET request, calling check domain once again with the added header collection. That way, it would become a security tool in addition to a keep alive tool. So, lots of ideas, lots of things to work on. Thanks for your time. This is Bill Kearns from Blue Kernel IT. Take care. Bye.